to transform the landscape, and they provide ecosystem services. For example, they'll help this landscape hold more water, and that will slow the flow and reduce flood risk locally. So we know Lower Greenford regularly suffers from flooding.
Imagine releasing a few beavers into a river long thought dead, and watching over several years as they turn it back into a thriving, vibrant ecosystem. Their dams slowed the water, trapped pollutants, and even reduced flooding, defying initial fears and scientific skepticism. Could such small animals hold the key to solving England's persistent flood problems and river degradation? This story reveals how a seemingly simple wildlife project sparked fierce debate, challenged human assumptions, and reshaped natural habitats in ways no one expected. It's a surprising example of how nature's engineers rebuilt a landscape and changed everything along the way. The return of a lost architect. In March of 2015, England took a dramatic step to address a flooding problem that had long seemed unsolvable. The Devon Wildlife Trust released a small group of beavers into the River Otter, an animal absent from English rivers for over 4 centuries. Initially, there were just 2 family groups, but within 5 years, the population had swelled to 15. What followed defied the expectations set by early ecological models, revealing a far greater impact than anyone anticipated. For centuries before the 16th century, beavers were key architects of Devon's river valleys. Their dams slowed rushing water and transformed steep streams into a patchwork of ponds and waterlogged meadows. This natural engineering held water in the valleys for weeks or even months, allowing it to soak into the soil and nourish plants far from the riverbanks. The rivers moved slowly, shaped less by the terrain and more by these persistent animals. This harmonious landscape changed when beavers were hunted to extinction for their fur and a special secretion used in medicines across Europe. By the late 1500s, no beaver remained in England. There is no record of the final slay. The species simply vanished. Despite their disappearance, the rivers and valleys retained echoes of this old structure for a while. Wetlands persisted, and floodplain meadows held water longer than they should have for natural reasons. Over generations, however, this legacy faded. Rivers lost their slow, spreading flow and became narrow and fast-running once again. Without beavers to arrest their currents, rivers cut deeper channels, sending water rushing unchecked to the sea. Farmers saw the drying wet meadows as an opportunity to drain land for pasture, believing the water had permanently moved on. The landscape changed gradually, so slowly that few noticed the loss of these wetland mosaics. By the 20th century, hydrologists had come to accept a new norm of river behavior: steep banks, narrow channels, and swift currents as the natural baseline. This normal was in fact the unintended legacy of centuries without beavers. The rivers were unlike those that had shaped earlier generations, yet this altered state felt familiar and unavoidable. Reversing those deep changes proved far harder than anyone expected. The reintroduction of beavers to the River Otter would soon challenge this accepted baseline, prompting questions about how much nature could heal itself when given a chance. The animal's slow return was the first sign of a shift in understanding rivers and flood management. Yet not everyone welcomed this new chapter. Tensions rose as concerns emerged from various groups who feared the consequences of this unexpected return. The vanished wetlands and shifting rivers. The disappearance of beavers set in motion a silent transformation of English rivers and the surrounding land. Their dams had once scattered water over wide floodplains, nurturing wetlands rich in biodiversity and buffering floods by holding water back. Without this natural regulation, rivers deepened their channels and lost the wetlands that had soaked up excess water and filtered pollutants. Farmers, responding to these changes, drained wet meadows to reclaim fertile land. This seemed practical because by then, water moved quickly through narrow river channels without lingering. What was lost over centuries often went unnoticed. Complex wetland ecosystems faded slowly, becoming memories rather than realities. Each generation accepted the degraded state of their rivers as simply how things were. By the 20th century, scientists built flood models based on these new river characteristics, never fully realizing they were modeling a landscape drastically altered by the absence of a keystone species. The river's swift currents and steep banks were seen as natural conditions, not the consequence of 400 years without beavers. This redefined normal-shaped policies and land management practices for decades. Flooding problems worsened steadily as these narrower channels moved water too quickly to always be absorbed downstream. The loss of wetlands, which acted like natural sponges, intensified the risk. Meanwhile, water quality declined as sediments and agricultural runoff were no longer trapped by slow-moving ponds, contributing to pollution downstream. The absence of beavers wasn't just an environmental loss. It had real consequences for communities living near rivers. Without wetlands to regulate flow, towns like East Budleigh experienced recurring winter floods that caused damage and disruption. Ecologists began to question whether restoring beavers might offer a solution, but such ideas faced entrenched skepticism. Farmers and anglers expressed concerns, fearing that beaver dams would worsen flooding or disrupt fish migrations. These fears were rooted in a landscape that had adapted to the beaver's absence. Reintroducing such a transformative species posed risks several had not anticipated. The interplay between the altered ecosystem and human land use made the return of beavers a controversial issue. Still, despite these challenges, early signs showed that the rivers might not only recover, but flourish, if both nature and people could find new ways to coexist. Early opposition and risks. The idea of releasing beavers back into English rivers was met with swift opposition from multiple stakeholders and government agencies. Early photographs of the animals captured by local resident Tom Buckley in 2014 triggered a call for their removal by the Environment Agency. The key concern was the risk of disease, particularly echinococcosis, a parasite carried by beavers known to threaten humans and livestock in some European populations. This was not baseless paranoia. Because the status of the Devon beavers was unknown, the possibility of them carrying harmful parasites posed a legitimate public health question. The government demanded medical testing and a clear assessment before allowing the project to go forward. This caution reflected the challenge of balancing wildlife reintroduction with safety. Meanwhile, the Angling Trust, representing nearly 900 fishing clubs across England, voiced profound worries about the beaver's impact on fisheries. Salmon and sea trout populations in southern England had been declining sharply, falling roughly 50% over a decade. From the angler's perspective, introducing animals that build dams across river channels could worsen the already fragile situation for these migratory fish. Farmers in the lower Otter Valley added another voice of concern. Many of their fields flooded every winter already, and the threat of more water backing up upstream created fears of further damage. While some, like farmer David Lawrence, supported the beavers, others saw them as a risk to their livelihoods, especially after incidents of farmland damage over 5 years, including the complete flooding of an organic potato field. In efforts to protect their land, orchards were fenced off to prevent beaver gnawing, and the government pressed hard for the beavers' removal. Yet public opinion began to shift, in large part due to grassroots campaigns from local supporters like Tom Buckley and environmentalists like George Monbiot. Petitions gathered thousands of signatures, and surveys showed overwhelming public support, reaching 90% favorability by 2019. Despite the opposition, scientific testing and ongoing monitoring slowly built a case for the beavers. DNA tests confirmed they were the native Eurasian subspecies, and disease screening found no parasites. This evidence challenged early fears and paved the way for limited licenses under strict conditions. The fight for the beavers' survival would continue, but the groundwork was being laid for a new understanding of their role. What began as a dispute driven by uncertainty gradually became a carefully managed experiment shaped by evidence. The risks were real, but so were the opportunities. Through testing, dialogue, and practical mitigation, supporters demonstrated that beaver restoration did not require ignoring human concerns, but addressing them responsibly alongside ecological goals. The story of opposition set the stage for a remarkable reversal, where the very animals once feared became agents of restoration and hope. The battle for survival and public support. Despite early opposition, the beavers found unexpected champions among local residents and environmentalists who saw their return as a chance to restore a lost ecosystem. Tom Buckley, a retired man who had installed camera traps along the River Otter, became the unintentional public face of the effort to save these animals. Without any formal organization or funding, he printed "Save Our Beavers" posters and quietly rallied support, illustrating how grassroots passion can sometimes outpace official efforts. The growing enthusiasm among the public contrasted sharply with the stance of some government agencies and stakeholder groups pushing for removal. Journalist and environmentalist George Monbiot criticized official authorities for what he called controlling behavior, emphasizing that many anglers he knew actually felt a deep connection to nature and did not share the angling trust's resistance. Public petitions and surveys confirmed this shift, with support for beaver reintroduction reaching 90% by 2019. The campaign's momentum convinced authorities to reconsider, but only after stringent scientific checks were passed. In early 2015, 5 adult beavers were trapped and underwent thorough testing that confirmed the animals were the native Eurasian subspecies and free of harmful parasites like echinococcosis. These tests answered the government's demands and earned the Devon Wildlife Trust a 5-year license to maintain and monitor the population under strict conditions. Researchers led by Professor Richard Brazier of the University of Exeter embarked on a rigorous 5-year study of the river otter catchment, surveying nearly 600 kilometers of waterways. They expanded the population by adding a new genetically unrelated pair to bolster genetic diversity and extend the beaver's range. The project was tightly controlled, with quarterly field visits and public reporting, creating transparency that helped build trust among skeptical observers. Supporters hailed the project as a careful compromise, meeting scientific standards while addressing concerns from farmers, anglers, and regulators. At the same time, local farmland continued to experience occasional damage, including flooding of an organic potato field. But these events were generally considered manageable compared to the larger ecological gains. Protective measures such as wire mesh around orchards helped limit beaver impact on agricultural assets. This balance between benefits and challenges reflected a broader truth, that ecological restoration often has winners and losers, and those lines may not always be neat. While farmers faced some inconvenience, the communities downstream began to see how beaver activity could reduce flooding risks and improve water quality. Public opinion increasingly leaned towards letting nature take its course, embracing the unpredictable but largely positive changes these animals brought. The persistence of beavers on the River Otter, despite fierce early resistance, marked a powerful instance of nature reclaiming space. It demonstrated how public engagement combined with solid science could overturn initial fears and open the door to restoration. Yet the full extent of the ecological impact was still to be uncovered by ongoing research. As the beavers adapted and thrived, the data revealed surprises that would challenge long-held assumptions about their place in the landscape. Scientific findings and ecological benefits. Over 5 years of close monitoring, researchers uncovered evidence that went far beyond what many had expected. By October 2019, the team counted 28 dams spread over just under 2 kilometers of tributaries within a nearly 600-kilometer catchment. Importantly, none of these dams blocked the main channel of the River Otter, alleviating fears about obstructing fish migration routes. The studies showed that beaver ponds contained 37% more fish than nearby river sections without dams. This challenged the long-standing belief that beaver dams are harmful obstacles for migratory fish like salmon and trout. Instead, juvenile fish used the slow, deep pools behind dams as safe havens, abundant in insect life and cooler in temperature, critical during hot summer months when river water temperatures can reach dangerous highs. One striking example came from upstream of East Budleigh, a village prone to winter flooding. There, a single beaver family constructed 6 dams, and measurements showed a clear reduction in peak flood flows passing through the village. This natural flood control was precisely the kind of benefit planners and residents had hoped for, but never fully expected from rewilding projects. Researchers also documented large-scale filtration of agricultural pollutants where beavers built their ponds. Runoff containing manure, slurry, and fertilizers settled to the pond bottoms, resulting in cleaner water flowing downstream. This effect was unplanned, but revealed a powerful ecosystem service, showing how beavers enhance water quality by trapping and breaking down contaminants. While these ecological gains became more evident, the study also highlighted an ongoing tension. Those living downstream enjoyed reduced flood risk, but upstream farmers sometimes faced water backing up onto their lands. It became clear that the beneficiaries of beaver reintroduction are not always the same people dealing with the costs, underscoring the complexity of balancing ecological restoration with human land use. The Angling Trust remained cautious, commissioning its own scientific assessments and expressing ongoing concerns about the beaver's impact on protected fish species. This scientific debate continued even after the project concluded, showing how contested environmental decisions often are. Yet the data increasingly painted a picture of coexistence rather than conflict. Beyond fish and water quality, the presence of beavers created new wetlands that had transformative effects on other wildlife. Water voles, a species that had been disappearing from England for decades, gradually returned to the otter area. Amphibians and waterfowl also found new habitats, benefiting from the diverse wetland environments shaped by beaver engineering. This growing evidence helped change the narrative around beavers, from pests to key players in landscape restoration. Their influence extended far beyond individual dams, strengthening entire ecosystems through increased biodiversity, improved water storage, and greater resilience to drought and flooding. Although careful management remained necessary, the findings demonstrated that beavers could become valuable partners in restoring damaged rivers while helping wildlife and communities adapt to environmental change. Their dams and ponds demonstrated nature's unparalleled ability to heal damaged ecosystems and provide solutions to problems like flooding and pollution that modern engineering struggles to solve. Growing populations and future prospects. Following the success of the River Otter project, beavers began to establish themselves in new areas across England, signaling a remarkable expansion of this once extinct native species. By 2020, beavers had migrated naturally from the otter into the river tail and smaller tributaries within Devon. Meanwhile, separate reintroduction efforts took place in Cheshire's Hatchmere Nature Reserve, the South Downs, and Dorset, showing a broader commitment to reviving beaver populations beyond their original release site. In northern England, beavers quietly made their way into enclosures and reserves as well. 2 adults were released into Cropton Forest in Yorkshire in 2019, and their family quickly grew. By 2022, the eldest daughter of this group established a new colony at the Sculthorpe Moor Reserve in Norfolk. These expanding colonies show how quickly beavers can adapt to varied English landscapes when given legal protection and space. Their growing numbers also coincided with a significant shift in their legal status. In October 2022, beavers received European Protected Species designation in England, placing them alongside bats, otters, and wildcats in conservation priority. This status made it a criminal offense to trap, injure, or slay a beaver without special licensing, reflecting a growing recognition of their ecological value and rights within the countryside. The momentum did not stop there. In February 2025, the government opened licensing for open releases of beavers nationwide. The National Trust received the first such license for a project in Purbeck, Dorset. These licenses require comprehensive 10-year project plans with clear exit strategies, ensuring that beaver reintroductions are carefully managed to balance ecological benefits with potential human conflicts. Natural England further advanced this framework in 2026 by announcing new licensed projects and launching an online mapping tool to assess potential release sites. This data-driven approach helps guide responsible restoration efforts and minimizes unexpected impacts. What began as a single trial in Devon transformed over a dozen years into a national program shaped by science and experience. This transformation comes at a critical time. When the river otter experiment began, only 14% of rivers across the United Kingdom were considered ecologically healthy. The Beaver Project is not an isolated success, but a hopeful blueprint for restoring degraded waterways and wetlands on a wider scale, addressing problems many thought impossible to fix. Mark Elliott, who led the Devon Project, described the resilience and adaptability of beavers as surprisingly profound. Their ability to breathe new life into damaged wetland ecosystems suggests that even heavily altered landscapes retain the potential for recovery. This natural renewal gives hope that England's waterways might regain some of their lost vitality through rewilding efforts. Farmers like David Lawrence, once wary of the beavers, observed how these animals manage their environment on their own terms. Rather than causing unmitigated problems, the beavers redistributed fallen trees and other materials in ways that balanced water flow and habitat needs. with 28 dams affecting just 0.3% of 594 kilometers of waterways and fish populations rising by 37% in ponded areas. The evidence confirms that nature's engineers can solve problems humans could not. As these populations continue to spread, the challenge will be maintaining cooperation between conservationists, landowners, and local communities. Careful monitoring, practical management, and public education will determine whether beavers can thrive long-term. Their return clearly proves that restoring one species can help repair entire landscapes for generations to come. The return of beavers to England's rivers is a story of nature's power to heal and restore balance over time. From near extinction to a growing protected population, these animals have reshaped landscapes, improved water quality, and reduced flooding in ways people once thought impossible. If you found this transformation inspiring, please like and subscribe for more stories about how nature surprises us all. Thanks for watching.